Emulate3D can be used to create digital twins that provide companies with a wide range of support, from impressive visualizations for sales support and realistic simulations for greater planning reliability to virtual commissioning, which saves costs by shifting commissioning from the plant to the office. Emulate3D models can be created based on 3D CAD data or the numerous standard components. This is where the standard Smart Conveyors library comes into play. The individual components are placed in the scene using drag and drop. Load creators and load deleters are used to create or delete conveyed goods and products. Snap functions support model construction and automatically take into account compatibility requirements between the components. Prefabricated controller components enable the control of material flows and movements exclusively via parameterization. The visual, block-based programming language QuickLogic is available for more complex controls. Scripts based on C# offer even more flexibility. Emulate3D offers the possibility to simulate movements based on physics using different engines, such as NVIDIA PhysX or Bullet. For certain applications, physics can also be deactivated and replaced by an event-discrete simulation. The standard library of Emulate3D includes a variety of robot templates from different manufacturers and types, such as articulated arm robots, SCARA robots, and Delta robots, and thus supports a wide range of applications. It can be used for animations and simulations as well as for virtual commissioning. The templates include both the 3D geometry and the kinematics of the robots. However, CAD import and kinematics can also be used to develop your own robot modules and store them in your own libraries. A common principle in Emulate3D for logically linking components is to drag so-called visual references with the mouse. In this way, robots are linked to the associated controllers. For example, robot movements can be programmed analogously to reality using point-to-point or linear movements. Emulate3D then calculates the trajectory curve using inverse kinematics with the help of an internal solver. Alternatively, various robot simulators can also be connected. In this case, they take over the control of the individual axes and the grippers. The simulated trajectory curves then correspond 100% to reality. For standardized applications, such as palletizing, Emulate3D provides ready-made and parameterizable modules. These include all the necessary functions, for example, for defining palletizing patterns. The QuickLogic Racks library includes modules for a wide range of different warehouse types. It is suitable for manually operated warehouses such as shelf, flow, and pallet warehouses, as well as for automated warehouses such as automatic small parts warehouses, high bay warehouses, and grid-based storage systems. The Vehicle Framework library contains a wide variety of vehicle templates and the necessary functions for controlling the processes. The library is suitable for all types of driverless transport systems, as well as for electric overhead conveyors and power and free systems. Driverless transport vehicles can move either freely or track-based. A dedicated library is available for simulating AMR systems. When using Emulate3D models for process simulations, the process speed can be increased. The modules from the data collection library can be used to log result data such as throughputs and utilization rates. These are then output numerically or in diagram form. The automated determination of optimal solutions is possible through the use of meta-heuristics. For training algorithms, Emulate3D can be run containerized in the cloud, enabling mass runs. Many of the ready-made modules can be used for both process simulation and virtual commissioning. Components can also be created based on 3D CAD data for mapping machines. In this case, the CAD as the model module is used. This allows both the kinematization of data and the creation of drives, controllers, and control panels. The created blocks can be saved in libraries for future use. A core component for virtual commissioning is the so-called I/O browser. It represents the link between the emulation model and the PLC control and is thus responsible for communication during virtual commissioning. The I/O browser supports communication with physical controllers from a wide range of manufacturers as well as with PLC emulators such as PLC Sim Advanced or FactoryTalk Logix Echo. When using emulators, these are operated as co-simulation, that means the clocks are synchronized. This also makes it possible to accelerate the simulation time beyond real time.